Hello and welcome. Today we're going to be talking about conditional probability. Now, this is one of those concepts in probability where it's actually quite difficult to wrap your head around. When you first do it, it doesn't really make sense for the answers that you're getting, okay? And that's okay. So we're going to sort of go through everything, but essentially, what is conditional probability? Well, it's the probability that an event occurs given that something else has already happened, okay? So we can talk about this in a variety of different ways. We'll look at our simple example in a moment to sort of illustrate it. But we might want to get our language and our notation out of the way, right? So the probability of event A happening, given that event B has occurred. So that's essentially what our conditional probability is. We write it with a interesting little notation here. You'll notice that we write P of A bar B. So that's the probability of A given B has occurred. Now, if we write it the other way, probability of B given A. So that's a notation that you'll see us use quite a lot throughout this video today, okay? All right, so it's really important to understand. You must understand that these two things are not equal. The order does matter. You'll see why in a little while, okay? Maybe not in this video, but in the next couple. So what we might do is we might have a look at this simple example. So two fair six-sided dice are rolled. You're allowed to assume the dice are the same color and for the sake of the experiment, the same weight, same everything. They're identical for all purposes, okay? For the first question, it says, what is the probability that at least 1 6 will occur? Okay, so we've done these questions to death. We understand this is a multi-stage event with the dice, so our tool that we should go to is a dot diagram or an array, okay? So the probability that at least 1 6 will occur, well, that means that we're going to have this outcome of having a 6, or we're going to have this outcome of having a 6, okay? So you'll notice in total, the probability of having at least 1 6 occur, so the probability of at least 1 6, all right? So a 6 on the first dice or a 6 on the second dice, it doesn't really matter which way we do it, all right, is equal to, you'll notice that we have 6 running down this vertical column, all right, 6 running down here, and 5 running down this one. We don't want to count this one twice because it's already happened, all right? So that gives 11 out of a total of 36, okay? Just using our outcomes from our dot diagram or our array, okay? So that's pretty straightforward in terms of what we're doing. However, what happens if I change it up? So it is known that a 6 is rolled on one of the dice, and then it's asking you, what is the probability that 2 6s have been rolled? Well, let's have a little bit of a look at it. So we know that we roll a 6. We're asking, what's the probability that we roll another 6? So physically, what we want to be thinking about is, imagine that I've rolled a dice in front of you, all right, and you've seen that it's rolled up a 6, and I have my other hand closed, okay? You don't know what the second roll is going to be. Think of your outcomes that you can have. Well, because I've already rolled a 6, I can't have a 1 and a 1. I can't have a 2 and a 1 or a 2 and a 1 in the other way. I also can't have a 4 and a 3. In fact, the only things that I can have occur in this column and row. So I can only have things coming from this column and from this row, okay? So now what I want you to have a look at is, well, how many chances do I have to roll 2 6s, right? So that's what it's asking. So given that we've rolled a 6, right, what's the probability that we get another 6? Well, we only have one outcome there. So essentially what we're doing, right, when we're saying this, and we'll write this using our official notation, the probability of 6, given that a 6 has already occurred, okay, that's how we write it, okay, is equal to, well, we have one outcome for a double 6 still. That's fine. However, you'll notice now, because we can't have, I might just highlight these in like a bit of a different color, okay, we can't have any of this orange, okay? So ask yourself, how many outcomes does this actually leave us with? Well, it leaves us with 11 outcomes, okay? All right, so we only have 11 outcomes in our sample space to pick from. So the probability of rolling a 6, given that we've already rolled a 6 on the first try, all right, is a 1 in 11. Now, you might be thinking, wow, that's actually pretty weird. All right. I didn't expect that result. And your answer would be correct with that. It's not meant to be natural. Conditional probability is one of those things that's a little bit funky. Okay. All right. But the main thing that I want you to wrap your head around with this sort of stuff is understanding that essentially conditional probability restricts the sample space. Restricts the sample space. So instead of having all of our 36 outcomes, we restrict it only to the common outcomes that we have. Okay. So in the next couple of videos, what I'm going to do is I'm going to show you how this works with Venn diagrams. And then we're going to make the concept a little bit more abstract using tree diagrams and where we derive the formula and such. Okay. All right. Thank you. I'll see you in the next one.